Good morning, good afternoon, and good evening. Thank you for joining today's webinar. Please use the Q&A feature to ask questions to the speaker. There will also be a follow-up email for the on-demand recording. And do check out the IBM Tech Exchange conference happening in October. And now I'll hand it over to today's presenter.
Well, hey folks, it's Rupert Gregory here from IBM. I am one of the principal product managers here, working primarily on the Sev1 product set. I've been here now for 10 years this week. It is my birthday week, so 10 years at IBM, for better or worse. But yeah, it's an enjoyable experience. Prior to that, I was in charge of network management. And also network engineering at several financial services companies. So yeah, I've lived and breathed networks for a long time. But anyway, thank you for taking the time out of your day. We're probably going to spend about 30 minutes here talking about application centricity and the importance of it in the context of networks. Hopefully you can all see my slides. If you can't, pop something in the Q&A box and someone will help you view them. And hopefully you can see me as well and hear me clearly. But let's get stuck in. So before we get stuck into the meat of the presentation, I just have to put the usual disclaimer slide up that all of this content is obviously copyright IBM. There may be forward-looking statements in here, and none of those are promises. And of course, your home is at risk if you do not keep up with your repayments on your mortgage. So with all that important stuff out of the way, let's get stuck into the actual meat of this presentation. And today we're talking about the importance of app-centric network observability. And what do we mean by that? Why are we even talking about it? Well, does it surprise? Yeah, it still surprises me every single day. More and more stuff is being driven by apps. Even when I go to my local park for a walk, there's a little person there with a little coffee van. And even if I go and buy a coffee, they've got a phone with a card reader and they can still take payments even in the middle of nowhere. And that's quite astounding, really, when you think about it, that, someone in the middle of nowhere with a little coffee van or a little snack trolley or something like that can take payments, that payment being, transmitted over a 3G, 4G, 5G network, backhauled to a data center, connected to a payment processor, processed in real time, and all the way back to that person's phone to say, hey, sorry, Rupert, you haven't got any money, so you can't have your coffee today. But apps are central to everything we do these days. And underpinning that, of course, is the network. And, whether these are on-prem internal apps that you only use within your organization, or whether these are customer-facing apps, or anything in between, they ultimately rely on the network. Without the network, you'd have no apps. And without apps, you'd have no reason for a network. So they go hand in hand. So not only is it critical to have that connectivity between your apps and your infrastructure, but it needs to be consistent and predictable and reliable. And that's a really key point here, is that, we use the phrase slow is the new down. So, yeah, now and again, people have hard outages. But if something's slow, even if it's only in the orders of milliseconds, you can lose business. People will leave your website. If they click add to shopping cart and it's sat there chugging away, people will leave. They'll go elsewhere. They'll take their business with them. So not only is it important to have reliable connectivity, it needs to be consistent and predictable, no matter where the user is and where the data is. And it's not getting any easier. Life is hard, right? But in networking, life is particularly hard. We first used this slide about 5 years ago now. Yeah, about 4 or 5 years ago. And we keep thinking we'll be able to get rid of it. But actually, the situation just seems to be getting worse. So, there's several key factors that are affecting, organizations' abilities to deliver reliable network connectivity. Part of this is the post-COVID world where, the way that people work has shifted. Yes, some of us are being dragged back to the office, but a lot of people, business is very much on the move, whether that's in the coffee shop or in their car. If you're a delivery driver, your phone is your lifeline and the connectivity behind that. Networks themselves are no longer, static. Gone are the days when things were cabled once and that was it, and it would run until it dies. Most things now have an element of software defined about it, whether you're talking about SD-WAN, SDN, or some other form of overlay network. And the way that network interacts with the underlay is continuously changing. And then the people that we need to support this, are becoming few and far between. Unfortunately, network engineering isn't as sexy as it used to be, which is a shame because it underpins pretty much everything we do in the world today. So being able to hire, really smart people is hard. So we need to do everything we can to enable them to answer questions and be able to identify issues as easily as possible. And we're still experiencing fragmented visibility, even more so now that your network is extending from not just your on-prem data center, but also your cloud, potentially IoT and industrial devices, and everything in between. And to illustrate that, let's look at the world as it stands today. For a lot of our customers and for a lot of the people out there, life used to be simple. You'd have your four walls of your data center. If you wanted to see where your packets were flowing, well, you could go to the data center, open a rack, look at the cables, look at the lights blinking away, and life was easy. But it's not like that anymore. That's not how modern agile businesses run their infrastructure. Networks are extended to the cloud, be it for services that we are delivering, or perhaps it's a SaaS application that we're consuming. I bet most of the people on this call will be using Office 365 or Salesforce or SAP or some other form of SaaS delivered application. And then there's the people connecting. Are they connecting from the coffee shop? Are they at home? Are they on 5G? Are they out and about on the mobile? When you get into the world of industrial and the Internet of Things, it gets even more complex. You have things like 5G connected tractors. Pretty much every tractor now has some form of telemetry coming home. Every modern car has a SIM card in it. How do you monitor and assure all of these diverse connectivity methods and the applications that run over them? Well, Sev1's pretty darn good at that. That's what we're here for. Whatever it is from whatever vendor, it's more than likely that we'll be able to support it, be it from a traditional large vendor like Cisco or Juniper, be it your enterprise Wi-Fi from Aruba, your SD-WAN from VeloClouds, your firewalls from Fortinet, Palo Alto, your load balancers from F5, your optical from Ciena, all of that, no problem. We can monitor that today. Expanding into the cloud, the big three clouds, AWS, Azure, and now Google. We support all the clouds. We will bring in all that data. And even the things that are connected to it. So be it Windows or Red Hat Linux or even Kubernetes infrastructure. Sev1 has the ability to collect data from these environments, monitor it, baseline it, alert on it, and take actions on it. And even if it's not a logo on that list there, as long as it supports a standards-based method of talking to it, such as SNMP or GNMI, WMI, API, or Flow, any of the versions of Flow, we will ingest that and make sense of that data. So great, here's some marketing slides. The world's all nice and fluffy and everyone's happy. But, what does this look like in real life? Well, we have a quote here from Devereux Advanced Behavioral Health. They're a health provider out in the US. And they took Sev1 as their monitoring solution, and it has helped them. It has helped them lower the mean time to resolution, or the mean time to innocence, depending on how you look at it. And not only has it helped them in the reactive method, but it's also helped them with proactive troubleshooting, capacity management, trying to find, issues before they actually become issues. It's helped them consolidate down a number of their existing monitoring platforms, roll out faster services to their internal and external customers, and ensure that whatever it is, wherever they are, they have that visibility that they need. So, application-centric network observability, let's dive into the actual meat of this. So what do we mean by this? Well, I've been using network tools now for many years. I always found it really interesting when they would come to me and they would say, "Hey, Rupert, what's the top talker on your network?" "Rupert, it's 173.194.184.200. Great. And I would go, "That's fantastic." But that means absolutely nothing to no one. It's just an IP address. That's not a person. That's not an app. I don't know what that is. I'm not able to look up IP addresses in my head. I don't have a full database stored in my head. I wish I did, but I don't. So how can we take the noise and turn it into something useful? And this is what Sev1 has been building on over the past year or so. So we can take this mumbo jumbo list of IP addresses and turn it into something useful, like who is your top network provider? Well, in this case, 42% of your traffic was traveling over Amazon CloudFront. Let's take a slightly different example. Here we have a table of application IP addresses. Well, now we can automatically map them to the ASN, the network provider, who owns that network, the company and the app that's running on that, and even the country where that application is, where that traffic's flowing to and from. And specifically, I want to highlight Slack here. So Slack is, like a lot of applications that we consume, Slack is hosted on Amazon AWS. So it's no longer enough to just say, "Hey, this is an Amazon network," because everything's hosted on Amazon or Azure or Google. You need to go to that next level of detail and be able to identify the fact that, yes, this is being provided, or this is hosted on AWS, but the actual application itself is Slack. So let's go a bit deeper. How does this actually look in the product itself? So start with the simple ones. So enriching the BGP AS and the country information for the data on your network. We live in an interesting time at the moment. There is unfortunately a lot of geopolitical instability in the world. So it's important to know where your traffic may be going from or coming from or going to. As we've seen, particularly in Europe recently, we've had a lot of high-profile hacking incidents, and during those hacking incidents, large amounts of data have been transferred out. Well, if you see a large amount of data being transferred to perhaps one of our less friendly countries, that would show up on here as a really big, thick line. You'd be able to see where it's coming from and where it's going to. Great. So now we know where our traffic's coming from, where it's going to, which countries, which BGP ASs. Next level of detail, the actual applications itself. So, as I said, it's no longer good enough to just have the network or just have the IP address. You need to know what those applications are. And we now ship out of the box the top 5,000 SaaS application fingerprints. It's there for everyone to use. You don't have to do anything. You just send us some flow data, and we will automatically enrich it and analyze it and surface those insights. And the important thing to stress here is that there's no deep packet inspection, no taps, no spans, no sniffers, none of that kind of stuff's needed. Just send us the flow data, any flavor of flow, NetFlow, SFlow, JFlow, CFlow, IPFix, we don't care. Send it to us, and we will analyze it and automatically understand the applications behind it. So now I know what apps are running over my network? What's coming in and out of my main connections? Where's it coming from? Which country? What services are they consuming? But there's a new kid on the block, right? Kubernetes. So Kubernetes has absolutely revolutionized the way that applications are delivered. But as a traditional network guy, it's quite a scary concept, right? So you've got this kind of mysterious black box in the corner of your network. Packets go in, packets come out. But what happens inside it? I know that there's lots of applications in there. I know that they can configure their own load balancers and they've got their own DNS servers. And there's something called an ingress controller. What is happening inside that black box? When they come to me and say, hey, I'm having problems with my Kubernetes hosted application, I'm like, well, I can't see inside it today. So we've been working with IBM Research and Red Hat to come up with a solution to this. And it's based upon a technology called eBPF. eBPF, fantastic technology, has really revolutionized the way that we can execute monitoring on the server itself. If you wind back about 5 to 10 years ago, or even 5 years ago, if I wanted like packet level visibility on a server, I would need to install a big heavy agent, and it would take tons of CPU resources, and it would eat all the memory, and it would probably crash and burn. That's not eBPF. eBPF has been built from the ground up to be insanely fast, supported right in the core of the Linux kernel, very safe to use, very lightweight. And by using eBPF technology and some software that's been developed with ourselves and Red Hat, the Network Observer project, you can deploy this into your Kubernetes infrastructure, and you can see inside that black box. You can see what's going on. And most importantly, you can converse with your app teams in a language that they understand. When you get into the world of Kubernetes, you no longer really worry about things like IP addressing. It's more important to talk about things like pods and namespaces. That's how applications are defined in the Kubernetes world. So if we take an example here, we've analyzed some data that we've received from the Kubernetes environment, and we can see that we have an application called Robot Shop deployed here. And we can see the various pods, which are servers or services that make up that application. So that's the network view. We can now talk in a language that our app owners will understand. If we look on the server side, normally I wouldn't be able to see this, but, for the purposes of this demo, I can have a look on the back end. You can see, again, everything's organized by namespace and pod. And if you've gone a step further and you've instrumented your Kubernetes environment with some form of application performance monitoring, such as IBM Instana, other products are available, but Instana is one of the best, then you can drill down by namespace and pod. And now for the first time, the network team, the app team, the Kubernetes infrastructure team, you can all converse and talk about exactly the same thing. So I'm just going to take a pause for a drink. Please do put any questions that you have into the Q&A. None in there yet, but do pop some in there if something, comes to mind. It doesn't even have to be related to app centricity, anything network and Sev1. So how does this play out in the real world, right? It's one thing to have marketing slides, another thing to see how, that relates to real life. And so we have a financial services company here. Unfortunately, I can't name their name, but they were going through some growing pains. Like a lot of our customers, they were migrating from their traditional on-prem environment, breaking elements out and putting them into the cloud. They were deploying and modernizing their WAN by migrating to SD-WAN and SDN. They took the opportunity during this to modernize their applications. If you think about financial services in particular, they've gone through a huge amount of change, whereby it used to be that if you wanted a bank statement, you had to print it out of the ATM, or you had to go onto a portal and download a PDF. Now it's expected that every single bank should have a nice, easy to use app 24/7. I can get my statement, I can get my balance. That's a huge change for financial services industries. And I'm migrating to the cloud, and I'm changing my network, and I'm trying to modernize my applications all at the same time. There's a heck of a lot going on. So this financial services company came to us and said, hey, look, we are doing all this stuff at the same time, and I just can't see what's going on. Some of the app guys, they're logged into the cloud. They can see, what's going on Azure. We've got our traditional network folk. They're looking at the on-prem stuff. We've got the app modernization team. They're looking at their tools, and we can't, sing from the same hymn sheet. So by bringing in Sev1, we're able to collect data from all of these sources, bring it all together, and enable everyone to have that simple, consistent view of what's going on in the infrastructure. Not only that, but we also introduce AI and ML to understand what's actually going on the network. And this is really important. It still surprises me how many tools use static thresholds, 80%, 90%. No, that's no longer the way that we can work. What you need to do is understand what's normal on the network, baseline that, and then alert when things deviate from normal. That really cuts down your alerting noise, and that means that only the real things that you need to look at get through and that you can take action on. And importantly, when we talk about actions, these are no longer manual actions. Remember back at the beginning, I said that, it's very hard to get smart people, smart network engineers now. This is where automation does come into it, and the world of AI. So taking those signals out of Sev1, we can then utilize products such as rapid network automation or IBM Concert workflows, and use those to actually take actions, collect data, open tickets, adjust QoS policies, turn up new connections, scale out apps. All of that can be done in an automated fashion based on the golden signal given by Sev1. So for this company, they are extremely happy. They've been able to pull in their data from across many disparate sources. They have it all in a single location in easy to consume dashboards. Everyone's now singing from the same hymn sheet. They can look at the same data, and they have reduced their volumes of alerts. They've reduced their outages, and the world is happy. So that's great. So I've taken you through the technology. I've given you 2 examples. What's next? What else can we do here? So I'm just going to round this out with one more thing for you all to think about today. If we go back to my diagram that I drew right at the beginning of this presentation, it's lovely, isn't it? Look, we've got some nice clouds, we've got some connections, the world's perfect, everything's lovely. But that's not really how the world is it? I've drawn a nice big cloud, but in reality, inside that cloud are thousands of routers and hops and fiber links and peering connections and transit providers and satellite connectivity and modems. And oh my word, there is so much going on in there. So how do I monitor the path in between my networks? How do I monitor the path that I don't necessarily own? Be this the internet, even in your private MPLS or private wire, how do I monitor in between? How do I know on a hop by hop basis what's going on? What's the latency? What's the loss? What's the availability? What route is my traffic taking through both my private and the public internet? Is it the cloud provider? Is it the CDN? Is it the DNS provider? Well, I can't say much more today, but this story is very much to be continued. Please do keep an eye on our socials towards the end of the year, as there'll be some exciting announcements in this space. And we believe we've got a really cool looking logo there as well. So, but yeah, really exciting new technology to come from us later this year. So let's wrap it up. IBM Sev1, network product that we all know and love. Application-centric network observability. Is it the me? Is it the network? Is it the app? Which country is it going to? How much bandwidth is that taking? What's the latency? Let's extend that out into the world of multi-cloud. Is it my on-prem infrastructure? Is it my enterprise wireless? Is it my SD-WAN? Is it AWS? Is it Azure? Is it GCP? Monitor what you own and also monitor the cloud that you don't own. And most importantly, take all of that data and don't just shove it all in a database. Do something with it. Take that data, baseline it, turn it into actions, execute runbooks, be it via IBM Concert Workflows or Ansible or Terraform or any of the other automation platforms out there. So hopefully that's been a really quick but exciting look at the world of application-centric network observability, how important apps and networks are to our everyday life. Everything we do is now connected, whether we like it or not. And we need to be able to enable people to understand what's going on. Please, if you're in Europe, enjoy the sunny weather. Be sure to follow us on LinkedIn and our other social channels. Join the Sev1 community on IBM. You can talk with other like-minded network-curious people. And with that, it's for me to say thank you very much for listening and enjoy the rest of your day.